What's up, everybody? Hope you are all doing all right. Today, we are going to be optimizing, hopefully. So I've been doing some sort of ongoing efforts to optimize this animation editor. You know what they say, first make it work, then make it fast, and then something else. I can't remember the last part. But anyways, we're in the make it fast phase because right now it is not the most efficient and it mostly works. So it's kind of good. Eddie Dev, how's it going? Good to see you. But basically, so if we go and pop open our metrics, so IMGUI comes with some metrics debuggers over here. I'm going to pull that right up there, and I am going to highlight my mouse so you guys can actually see what I'm doing. Let's see if we can do a... I forget what it's called. Let me just open up. Nope, that's not going to work either. Okay, let's open this up real quickly. Go to the desktop. I've got something here that should, there we go, cursor highlighter. That's what we want. All right, so now you can see my cursor. Hopefully you can see this as well. We are running at 60 FPS, give or take. This is averaging it, so it's actually calculating like a pretty accurate FPS, averaging the last X amount of frames and getting a frame rate based on that. I'm not exactly sure, but I've looked at the code. It's pretty good. 16 milliseconds per frame, pretty good. So that's, and it's locked my refresh rate, so it could probably go faster, but it is what it is. Real hi, bye, hello. How's it going? Hi. Good to see everybody. So basically, if we go through and we start playing this stuff, you can see we stay at a pretty good FPS. And this maintains its validity until we add something a little bit heftier. So I'm going to add in a text object that's a big text object. And this is going to start slowing things down a bit. We're also going to go ahead and throw it into this create animation so that we are using it. So let's throw him in there. Let's select a font. Going to go ahead and just choose Baskerville, which is a pretty hefty font too. So right now that's a small text object. There's not a lot in there, but if we go ahead and make this a pretty long sentence, you can already see my frames are tanking. I am down to 16 FPS, but after a few seconds, it recovers and we go back up to 60 FPS. So I've been working on some optimizations, as you can see, that help fix this. And I can move this around. I'm not losing my FPS now that we've rendered this. And the reason it was like slowing down so much is if we pull this up, this is kind of our cache. And you can see if we look in through here, what happened was it started doing this over and over again. It'll clear out the cache once it's like filled up. So right now it just repeats it a million times because I think that's what was happening. Let's see. Do we have no, yeah. So the reason it repeats it a bunch of times is because like as I'm typing new stuff out, it keeps recalculating it and then it'll clear out all the old stuff once this whole texture fills up. So nothing to be worried about there. But my point is now that it's rendered there, I can go ahead and like move this around. It doesn't really lag anything because we're just splitting a pre-rendered texture to some quads. If I go ahead and were to increase this scale, so if I increase that to 200, it's going to drop my frames, possibly, when I move this. There we go. So we got like different stuff here, and it basically re-rendered it. And it drops the frames for a second when it recalculates that, but then it picks it back up as it's using that cache. All that to say, it's part of an ongoing effort to help out with rendering these big scenes when you get a lot more text, which tanks the FPS. Yeah, that's not good at all. I'm gonna have to change this, hopefully, so that it doesn't crash like that every time you do little changes and stuff. We'll look into that eventually. For now, though, one of the things I want to add to aid in this effort is right now, it's good, but you can see once I start moving my cursor around like that, it starts slowing down pretty bad. And the reason it's slowing down like that is because every time I have to calculate new things, I have to refresh this texture. And so what I want to do is I want to basically take snapshots of the scene and snapshots where it changes, right? Because if I'm moving the cursor around here, it shouldn't be lagging anything because technically nothing up here is changing. All of this is the same, nothing should change. But I can't tell that right now because I have no way to actually see that in the code. And so that's what this stream is going to be about, is creating some sort of data structure that mimics what we see here. That basically tells me, hey, here's what the scene looks like if you move the cursor here. And then I can go and like grab that if it's cached or recalculate it and cache it. and then we're not wasting a bunch of time. And then I'll have snapshots at the important points, which would be like right here. Snapshot would be here, here. So the beginning and the ending of each animation is where we want those snapshots, and then we can kind of just jump around and it should just work. Another guy in the chat, how's it going? I just saw your name there. So that's the goal of today's episode, a data structure to mimic this timeline so that when we go ahead and we start playing these things, we can use pre-cached results and we don't have to worry about this horrible lag because we won't be worrying about that. So yeah, that's the goal. How's it going, TB? Good to see you. And I guess I should mention too, so this whole thing right here is like an animation editor thing. So if I play this animation, we have like, it says hello, writes that in, switches to goodbye, it morphs that animation, everything. Sam, subscribed. How's it going, man? It's good to see you. For 5 months on a 3-month streak. Thanks. But yeah, so this is what I'm doing, all in the efforts to make my YouTube videos faster. It's been like 200 days since I've last released a YouTube video, so it's not exactly helping in the short term, but it has been very fun. So that's good, I guess. But yeah, so we have this whole editor thing, and we can go ahead and like change all this stuff. If we go to the editor view, we can like drag stuff around. You can see that didn't really do anything because it's changing the position of this guy, which was kind of hard to tell. So you can see I have it selected over here instead of this one. If we go and select that, I can also change like individual letters. And then if I wanted to fix that, like put it back where it was, I could just change the text here for this one and it'll regenerate things. Yeah, so you see it regenerated, it repositioned it. I need to come up with a better solution because that's not very intuitive, but you know, the UI is a work in progress. We'll see how that goes. Anyways, for now, we need a timeline thing that can represent this timeline. So we need to see how that goes. And I'm kind of concerned that it's kind of lagging here is what it feels like already. And this is in release mode, so that's not very good. This should be an easy scene to render is what I'm saying. So not quite sure what's going on there. I'm curious too. Okay, so we're at 1.4, 1.2 gigabytes of RAM. So that's another thing. I'm not afraid to use up more RAM for this data structure since it's hopefully going to help keep the scene optimized. What is it slowing? What is it slowing when you just start adding more text? I wonder, you just make a mesh and batch it with just one draw call. Oh, so that's probably a good idea. We can go a little bit more into why exactly it slows down when I move it. I'm trying to think. So the best way to do that is I'm going to force it to re-render the cache every frame. So if I go into the application, we can go down here. Okay. It's been a while since I've looked at this code. So if we go into here, we check if the delta is 0. Oh, I have something in here called like a SVG cache. And I think that's what's actually checking it. Wait a second, go back up here. Oh yeah, so we have this SVG cache. Okay, and I have if delta frame does not equal 0. So if we just remove this and clear it every frame, it'll start slowing down more. And then we'll open this up in RenderDoc, which will show why it's going so slow. So this is the unoptimized version. It's not bad because it's a small scene, but if we open it up in RenderDoc, we can kind of see exactly what's happening a bit clearer. Let's close that out, pull this over here. So let's go ahead, open this guy up. This is in here, and I'm gonna go ahead, I was in release mode. So we want to grab that. Let's go ahead. Animations, that one. And Real Hi Bye Hello, thank you for following. Okay, so we've got that. I just want to change my working directory as well. All right, so if we launch this in RenderDoc, not sure why it's asking me about this. Okay, if we open this up in RenderDoc, let's do that. We're gonna grab a frame. We'll grab this one because it's gonna be rendering a lot more. So I hit F12 there. That should have snapped a frame, which it did. And now you can see the NanoVG render pass. This is the NanoVG render pass. NanoVG is great. It's like SVG rendering on the GPU. It's great, but it's really slow and it generates a ton of draw calls for what should be relatively simple stuff. So This is what slows things down. And then once I turn on my cache, which should cache these intermediate results, we basically go down to like 2 draw calls. So that was probably like 100 draw calls there at least, if not more. So let's go compile that. And then if we open up RenderDoc again, I shouldn't have closed it out. I should have left it open. But if we go ahead, open this back up, open that up. Okay, so then if we go into here, this is the same frame. So we're doing the same thing, except now I'm actually using the cache. And so you can see Nano VG render pass does nothing. I just have it there, but it's not actually doing anything, no draw calls. And then the main frame buffer fast, now this is all we're doing is we're just doing that, clearing some texture images, and then we just do a 2D general pass, which just does 2 draw calls. So 1 draw call for the textures. This is where we're blitting the textures. If we actually went into the texture viewer, or maybe the pipeline state is what I'm looking for. Maybe my computer's just being slow. I don't know. Oh no, mesh viewer is what I'm looking for. Yeah, so then we look at this. I'm just blitting the textures to quads. So you can see that here. It's just the text is there. And if we go back into here, texture viewer, you can see that's the goodbye kind of mixture that we're getting there. So anyways, we're reducing like hundreds of draw calls to just these draw calls. And there's nothing I can do about Nano VG to fix that. It's just the way it is. And I've looked it up. There is no such thing as real-time SVG rendering. And so this is kind of the best I could do. Well, what I'd like to do in the future is have some sort of like buffer where we don't actually drop frames if you're in the middle of rendering an SVG to the cache. That way, when you're like kind of moving around and stuff, it doesn't actually drop frames. It just starts rendering them, and then it'll cancel the operations if it's in the middle of it and it can't complete it. All that stuff. And then having more buffers too. Right now I just have 1 texture, but I want it to grow dynamically so that you can add more textures as needed. That's in the future. Anyways, for now though, what I want to do is I want to minimize even more those kind of state changes, which we can do by mimicking the timeline as a data structure. Because right now what I'm doing is I'm iterating. So when you change the cursor, I iterate through every single animation, which isn't a lot right now. It's just 2. And then we basically go and progress the state of the world forwards. So I apply this animation to all the animation objects and effects, which we can see inside of here. And that goes recursively and hits all the children as well. Same thing here. What I'd like to do is like if I move the cursor from here to here, clearly nothing is changing on the scene. And so I want that to reflect by basically saying, hey, use the latest snapshot of the world, which would be this. And then if I move to like a new snapshot, say there's another animation here, then it would change based on that instead of recalculating everything every time it changes. So yeah. Adrian DeWinter, thank you for subscribing with Prime. Good to see you. And Real High by hello. RenderDoc looks very handy. Too bad it's not running on Mac. Oof. RenderDoc is very handy. So hopefully they get it fixed on Mac or potentially get it some sort of version working on Mac because that would be nice. But yeah, so anyways, that's the goal of today. I've already kind of started thinking about how I want to do this. I'm still not quite sure how this is going to be achieved, but we're going to try something at least. And so my idea is this is just like a linked list. And I just need to have some way to save these snapshots of the scene at each point. And I should be able to just go directly to that point and then take that snapshot and render it. And if stuff is already cached, that should already be picked up. So yeah, we'll kind of see. Sam, I think I would create some big buffer that would store all the text mesh and just do 1 big draw call of text that fit inside. And see, since you don't need to create the text mesh every frame, only if scale letters change. Create all the text mesh and do 1 big draw call that. Okay, well, so the problem is I can't do like traditional techniques here. I've thought a lot about this, trust me. There's a lot of stuff. So I can't just like store the text in 1 big mesh if we pull up the debug window because of animations. So you see how the letters are changing there, and you can see up here, this is the mesh that's, or I guess this is like the texture, the cached textures that are rendering it. And so the problem is I can't do this. I could store like every single frame of this, but I've done that. I tried it. And if you store like every single frame of just this animation, it fills up the whole texture. And this is a 4K texture, so I don't want to be doing that. But anyways, I can't just store each letter because say you have this and then I have another track here and we have another text object we'll just leave it new object, grab a font, move this here, and then I'll have another create animation down here that's offset a little bit. Okay, and this one's a different length, all that stuff. We're gonna go ahead, add this object here. So even if it's using the same font as that one above, which this one's using alger.ttf. Wait, no, it's not. Oh, I have to click it up here. Okay, so this one's using Arial Bold. We'll use that. So let's go to Arial Bold. Okay, so same fonts and everything, but we can't save the letters. I mean, you can see I kind of saved the cache and stuff because this, even though we're using some of the same letters, is in a different creation state, and it's the same if we change. So even though we're the same letters, we have to like render at different points. And so this just messes with everything. Usually I would just render like a big cache full of all the font, like the letters, and then use that, you know, as a font atlas. But because of the way the animations work, I can't do that, and it just makes things harder. If that makes sense. Hopefully it does. But I think what I have right now is the best solution, and I plan on adding support too, where if we look at the SVG cache, we already use some properties from the SVGs to like figure out if it's already rendered. And if it is, we just return that render, kind of like the UVs and stuff. And so I just need to add different identifying things so that we can reuse more stuff. So if I go down to, what's it called? There's something in here. Okay, this is what hash. So the hash function right now uses the percent of the SVG that's created, the scale that it's rendered at, and then we use that to hash the actual SVG object and the object ID. So eventually I'll change this to like get more features, which ends up making it so that we can reuse certain features that are already rendered in here if they're at the same kind of states, which is the overall goal, if that makes sense. Sam, I mean, you can just fill the buffer every frame and do one draw call. Like this, you can do animations as well. Yes, and that's what it is doing right now, basically. Except once the frame ends, and especially if like you're in here, I don't want to be re-rendering things, because as soon as you get lots of text, it's slowing things down because we're doing that. Right now, it's fast now. Right? So we have 60 FPS here, but if I start changing things, you can see it starts to lag really bad because I have to re-render all of these letters, and it's a lot slower than you would think. So the goal is if I'm moving the cursor around in a space like this, I should not be re-rendering the whole scene because there's no reason to. And the ultimate goal is I shouldn't be re-rendering the whole scene ever. I should only be re-rendering parts of the scene that are actually changing when you move the timeline cursor or anything else. But like once I have it pre-rendered, I can move it around and stuff, and it's fast, and I can even scale it up more. So if I do like 2x2 scale, it's not positioned appropriately because it's just doing like basic, like these are all their own game objects and stuff. So it kind of messes with things, but hopefully kind of gets the point. And then I'll move that scale back down to 1. I may eventually try and figure out a way to apply that scale to the letter spacing too and let you kind of like regenerate the positions and stuff, because I feel like that makes sense. But yeah. So we'll see how this goes. I don't know. Right now, I just want to get this timeline so that like basically if I move around the cursor in here, we should get no lag because it should detect that the scene isn't actually changing, and therefore we shouldn't have any lag. So yeah. And especially like if we don't need to re-render any of the SVGs, it should not re-render them. That's the ultimate goal. Only re-render things that actually need to be re-rendered. And that should speed it up, hopefully quite a bit. We'll see. Okay, so on that front, what I've done is I wrote my own font running with STB free type, and I can't figure out the font baseline since when I change the texture, it just shifts the base around the text bounds. Every single time I write font renders, I swear, it doesn't matter how many times I've done it, I always end up just fiddling with the baseline until I get it correct, because it always messes up somehow. And like I always have, I probably have it open right now, honestly. No, I don't have it open. Well, that's good. But I always go to free type font metrics because I can never remember how it's supposed to go. And I always go to this chart right here. And I use this because I'm usually using free type, but it works with like general true type fonts and stuff too. And I use this to try and figure out how to set it up. And it never works right, but I fiddle with it. And then eventually it works out, but it's always very annoying. All right, so right now, we have this thing right here. This is kind of like the animation object. This is what's currently being used. And you can see I've got these like rotation start, rotation, blah, blah, blah. And these were kind of like snapshots that I used to calculate deltas and everything. But now that we're doing this global snapshot thing, it'll be nice because we only have to store the state of the object as it is at that point. And then I can apply deltas kind of between things. Hopefully this makes sense. If it doesn't, say something and I'll try and explain it a different way. But this basically just represents the state of one of those objects, right? We have the type of the object, which if we click into here, we can have a text, a LaTeX, square, circle, cube, axis, SVG, and more in the future. And then we have some things that apply to all of these, so like position, rotation, scale, transforms, right? This is like the SVG object. So you can put any sort of SVG thing inside of there. It can be a group, it can be whatever. We have the scale, which just represents how the resolution of the object, I guess. And then a few different things. These are kind of like the state pieces that each animation object should have, but there are a few other things that aren't related to the state, like the ID and the parent ID and the generated children. Those things are kind of central to the object itself. Yeah, and I have it here in the state. I don't think that's quite necessary. Maybe it is. We'll see. Anyways, what I've done is I've tried to extract out all the state pieces, like the pieces that are just related to state. And so what we're going to do is have some sort of delta. And so let me switch to my drawing screen so that we can kind of see this a bit better. So I want to switch to this delta where basically, like say we have a timeline, right? And this timeline has animations. Each animation has a start and it has an end. And so we're going to have our start state, and yellow is kind of hard to see. So let's switch to purple. Okay, so we're gonna have our start state and we're gonna have our end state, right? And then basically what we're gonna do is kind of like what I have here, where we're gonna have like animation 1, and this is all just gonna be in an array. And so basically this would be animation 1. So if we actually wanted to draw this out, go ahead and do that. So say we have an array. This will kind of be like our timeline, right? Because time goes forwards. And let's make this a little bit more complicated. Let's say we have 2 animations here that start at 0. All right, and we'll call this animation, let's give these IDs. This is 0, this is 1. Let's make this more complicated too, because the IDs don't necessarily go in order. They can be any order. So let's make this 10. 6, 9, and 7, okay? Because IDs don't matter. They're just identifiers. What we want to happen is we want the timeline to be represented in here and to go in order. So this would go into slot 0. This one would go into slot 1. And what we're going to have is the track gets preference. So if it's on track 0, which these do have orders, 1, 2, and it can keep going down, track 0 gets preference over 1. So if they start at the same time, this one will go above this one. And then what would happen is this one's the next one because it's the next time slot. So that would go right in the 3rd slot. And then we will get this one in the 4th slot. Right? And what does this array hold? It holds this object I've called anim object state delta. Maybe. This is where I'm kind of trying to figure this out. Scratch that. What we're going to do is we're going to hold something called scene delta, okay? And a scene delta is basically going to hold a snapshot of the scene for the start. So what does it look like here? And what does it look like here? And then snapshot end. I just realized this is going to be even more complicated now. So my goal was, like, if the cursor, which is represented by this red thing, is right here, what we could do is we could just go into and find like the snapshot of the scene at this point in time. Yeah, okay, actually, no, this does work. So we go and we find the snapshot of the scene in time. And so what we would do, right? So we basically want to find, let's erase some of this stuff so we can see a little bit better. Okay, so thinking this through. Let's say the cursor is right here. If I want to figure out what the snapshot should be, like which snapshot we should use, what I want to do is I want to find the earliest time code. Wait, let me think about this. Yes. Okay, we're not going to have snapshot ends. So I want to find the earliest time code that would actually encompass this. Wait. Okay, my mind's kind of being blown here. I thought I had this figured out, but now I'm kind of thinking about it a little bit more. Sam check, it's 2 a.m. here and I'm waking early today. I will watch the VOD later. See ya. No problem. See ya. So, how do we figure out the state of the scene at this time code? That's the hard part. My original thought was I was going to say, oh, we could just go to the beginning of this and then apply these animations until we get to this time code. Which that kind of works. Yeah, that actually works. Okay, yeah, okay. So let me think about this again, just a little bit different. Change my mindset. So, and sorry if this is a bit weird to follow. I'm just trying to think through a solution right now. So, and I've thought a lot about this and come up with bad solutions. So I'm trying to think of one that's going to work, hopefully for good. Okay, so basically what I need to do is I need to figure out where we can take snapshots in a scene. And the place I want to do that for is at the beginning of animations, right? So in this case, what we would do is we would have a snapshot here. So this will be a snapshot. But since there's two animations that start at the same frame, this is just one snapshot because we don't need two snapshots. Then we would have a snapshot here because the start of this animation is here. Okay. And then we would have a snapshot here. Okay. I love making diagrams. They are handy. I made one to make a FIFO buffer work correctly. Yes, diagrams are the best, and especially when it comes to stuff like this where you have to think through this critically because it can get difficult. Okay, so I think this is what I want to do, where basically we have snapshots of the scene at these different positions, right? And these positions are where the start of a new animation comes. So then if I look at the time code here, the cursor, instead of having to go through from the start of the scene, like say there's a bunch of extra stuff in the back of here, we can basically just go reverse from this time code and find the first snapshot, which would be this one, and then apply everything from that point forwards. Yeah, okay. So then we apply everything from this point forwards, and we only apply whatever changes, which would be this animation and this animation. And then that way we wouldn't have to touch this one, and we wouldn't have to touch that one. And hopefully this works out well. Yeah. Okay. We're going to go with this. We'll see what happens. I may have to change some stuff in the middle of it, but this is at least a starting point, which is all I need right now. So the first question I have to ask is, how do I take a snapshot of the scene? Well, we have this thing called Animation Manager Data, and this is basically the current state of the scene. And how do we store that? We store that just by doing this. I think it's just this. Like literally we just have these objects, and then this object ID map is just like an indirect way to get into here, like figure out the index. But yeah, and I think that's all we need for a scene snapshot is this. So let's call this struct scene snapshot. Okay. That's going to contain this. And then to start, what we're going to do, we're not going to need this, is we're going to have, instead of this, I'm going to say, this is a scene snapshot now. And what this is it's the current snapshot. This is basically the current state of stuff. Yes. Okay, we'll start with this. This is how we'll go, and we'll see if we can get this working. Okay, so we have this current snapshot. I'm gonna have a bunch of errors because now I've broken a lot of stuff. But it's easy because we can just do that, dot objects. I basically just need to add this in front of everything, and we should be good. So let's go ahead and do that very quickly. Just add that, and it's getting kind of long and gross, but it is what it is. Okay, we'll do that. And that. This was some other things that I was tinkering with, but we can get rid of it now because this is not going to be used. So let's get rid of this. Let's get rid of that. Dead code is not good code, or zombie code is what that's called. Okay, we'll do that. All of this, and we're almost there. I would do a control replace too, but that never ends up working well, unfortunately. And sometimes it takes just as long to fix it as it does to just go through and do all this manually. So maybe if I used Emacs or something, I know they have good key bindings in there, and that would be helpful. And I wouldn't have to do it this way, but until I switch, this is how it's going to be done. Whoops. Okay. Almost there. Almost there. Okay, cool. So we're there. We did it. I think I might have one more error up here that I missed. Did I? No. Okay, we're good. So basically what we're going to have is we have the current snapshot, but then what we want is a list of snapshots. And I'm going to use a vector here because I'm using it in other places, so may as well. And this will just be our snapshots, right? So we have a list of snapshots. And yeah. List of snapshots. We have the current snapshot. What we need is we need a way to figure out which snapshot based on the time code. So each snapshot will also have a frame associated with it. We'll call this the absolute frame. Frame of the animation that this correlates to. Right, so that way we can tell, and actually this should be there are no negative frames, unfortunately. Maybe there should be, but there isn't for now. Okay. Let's see if this still runs. I guess that's probably a good point to do. All right, we're still good here. Still running. I think it gets laggier as we go on too. Because this is going pretty fast, but I remember it getting kind of slow. Weird. Okay. We're going to have to see about that too, because I feel like as I was typing different things, it slowed it down and it stayed slower for some reason. And I have no idea why. I don't think it's a memory leak because the memory stays constant. So I'm going to have to look into that more, but that's a future me problem. For now, we basically want to build snapshots. And when do we build snapshots? Let's go. I'm going to have to change this too, because right now this is anim object, but what we actually want is anim object states, object states. I'm trying to think. Yes, this is what we want. And that's spelled wrong. Object states. Okay. So we've got that. And now I'm trying to think of what the best way. So we're going to want like some way to build a snapshot. So let's just add that. We're going to have something in here. We will call this void build snapshot. And we're going to do this, and this takes in a frame. Okay, so let's go ahead and write this. Let's see if we can figure this out. If we can figure this part out, then the rest of it becomes easier, I hope. Okay, so given the animation manager in the frame, we want to get a snapshot of the state of the scene at this point. And I already have a way to do that. It's up here. No, it's down here. And I think it's called render. Yes, okay. So let's copy this, and then this is gonna get taken out eventually. So we'll do that. Build snapshot. Okay, here we go. So how do we build the snapshot? We go ahead, we make sure that this isn't null pointer, just a sanity check. We do not need to worry about this. Let's go ahead and do that, and then I'm gonna have to take out one of these. Let's do that. Okay. So we don't have to worry about this. We're not actually modifying anything. Get rid of that. Get rid of that. Okay. So we put everything to frame 0, which this is kind of like the start state for everything. We reset all the object positions. Okay. In this case, I think what we're going to do though is we're just going to have something in here that's going to help out with this. Let's go up here. And we're just going to call this starting snapshot. Okay, so we have our starting snapshot. This is the state of the scene before any animations get applied. We have our current snapshot. This is what frame we're currently on. And then we have a list of snapshots, which we can go directly to any point in the scene. Now, to build a new snapshot, we're going to go to the starting, and then we're going to go and apply each animation in turn to get to the point that it should be here. So yeah. Implody, any reason as to why you explicitly use the iterator versus a for each loop? I just don't like hidden stuff. C++ has a lot of things that are just not visible, and I don't know. I just like being able to see exactly what's going on. Like, I know you can do like for object iter in am current snapshot, right? You can do something like this, dot objects. Same thing. Not sure why it's not happy there. I think it's something like that. I don't know. I haven't done a for each loop in C++ in a long time, but you can do something like this, right? Where it's basically like you just loop through each one and it implicitly gets the iterator for you. But then it's not exactly clear what's going on, at least to me. And I feel like that's what you get with C++ for a lot of things. Like, you know, you can have your std path equals, right? To somebody coming from a different language, it's not clear at all exactly what's going on here. If I were to create this, make that an actual path, I think it's going to implicitly combine these. Yeah. So look, I'm using the division operator here to combine these paths, and I really just don't like this. So it doesn't go well with me. I like the code to be as straightforward as possible and show me exactly what's going on. I guess that's kind of the reason I do it. But yeah. I just recently used my first for each loop in C++ yesterday. I normally just use iterator. Yeah. Oh God, division operator. Yeah, that's what I'm saying. It's like you can do these things in C++, and I feel like it just makes it a lot harder. And so, especially in my code, I try to make all my data structures and stuff like this is a struct. And the reason I call this a struct and not a class is because it doesn't have a constructor. It doesn't really, I don't mind functions in here as long as the functions don't actually do much. No, yeah, I don't mind functions. It's just constructors and destructors that I don't like. And like copy constructors, move constructors, all that stuff. I just don't like thinking about that. And so I try to make my data structures as straightforward as possible so that it's like, okay, this is exactly what's going on. That's why I like math libraries especially, because like you go into here, you know, and you look at a vec2 or whatever, and it's just this, you know exactly what you're looking at. There's nothing fancy, and you can overload operators and stuff, but you don't actually have to put them in the class. You can put them like in here or whatever. I think I've got add functions and all that stuff up here somewhere. But anyways, yeah, it's just kind of personal decisions and the dialect I've settled on. Structs are indeed handy, yes. Okay, so building a snapshot though, we start at frame 0. So we want to put everything where it was at frame 0. And I'm wondering, the camera, I need to make the camera an actual game or object in the scene is what I need to do, because I don't like this. But that'll come later. For now, I guess we can include it in here. Yeah, because I guess we have this camera position. So I guess for now, what we'll do is we'll just include the camera, the 2D camera's position. So we'll have that in there, but that will change. So anyways, what we'll do is we'll say, instead of this, this is position. Yep, so that equals, and then what we're gonna do is am start snapshot dot camera 2D pose. Okay, so we reset that to 0, and then we want to reset all the objects to whatever they were at this position. And I guess for that, what we can just do is copy stuff, because that's what we're doing anyways. But I have to be careful with the way I copy it because I have this stuff, which is a little bit more finicky. So and technically we're building a new snapshot here. Ooh, okay, yeah. So we're building a new snapshot here, which means what I probably want to do is I want to say scene snapshot. We're going to do this. Yeah, okay. So what we're going to do is we're going to do that. We're going to say new snapshot dot camera 2D pose, and then we're going to copy everything inside of the starting snapshot and just kind of progress things forward. So we do that. We want to reset the positions now and everything else. Reset all anim object states. So we want to go through this. And this. Okay. Then we want to reset everything. So since we're making a new snapshot, what I'm going to have to do is I'm going to have to say new snapshot dot objects dot pushback and then we're going to give it a new object. Okay, or I guess what I'm going to do is I'm going to do in place back, and we're going to give it some object that we just create, because we have to copy everything. So we're going to do that. It's going to get that, and that's going to be after everything, I think. We'll see. Okay, so reset all the anim object states is what we're doing first. We create the object. And I actually need to do something. So I think I can do anim object create default from object. Ah, we can just do this. So this is nice. So we're going to give it animation manager. Ooh, but this isn't going to do exactly what I want, I don't think. Let's see what this does. So this calls that. Yeah, this isn't going to do exactly what I want. I think what I want is just a copy function. So we're going to write that up real quick. Okay. There's a lot of unorganized stuff in here too, by the way, because a lot of it is very hacked together, and I'm kind of cleaning up as I go different parts of it, but it's still very messy, and there's a lot I would like to change. So yeah, but what we're going to do is we're going to go ahead and just create an anim object, create copy. And for that, I'm just going to take in from this. Okay. We're going to do that, and we will just use this instead because this is nicer, I think. So that's going to be right below create defaults, which is right here. Okay. And the reason this is its own thing is because I don't actually want to add it to the scene. I might make that explicit in the function signature too. This is a create copy. Yeah, just create copy. I don't know. Because usually what happens when you create a new object is it increases the ID counter and gives this object its own unique ID. But yeah. Implodey, personally, my biggest gripe is the implementation definedness of std function, especially how there is no control of the internal small allocation buffer. See, those are things that I definitely do not get because I just don't go into the intricacies of the C++ language and try to use the simplest features that I can because there's just so much gotchas and everything. I was actually reading today. Scott Myers. Let's see. Cannot trust myself. C++. He has a blog. So Scott Myers wrote Effective C++. And he has something. I think it's this one. Yes, it's this one. Okay. So I don't know if you guys are familiar with the books Effective C++. They're very good books written by Scott Myers, and he's written several of them. Yeah, so you can see he's written several of them since like the 90s. This guy knows the C++ language very well. And this is from him. He says, I no longer plan to update my book to fix technical errors. It's not that I'm too lazy to do it. It's that in order to fix them, I have to be able to identify them. And this guy has been coding in C++. He must be outdated. No, he's went up to, I think, like 2015 was the last book he released. This is 2015 is when he's writing this. Oh, no, this is 2018. But this guy is very smart. Yeah, he knows the C++ language inside and out. And he says it's that in order to fix the errors, I have to be able to identify them. And that's something I no longer trust myself to do. He says, if you write books and you're anything like me, you make mistakes, lots of stuff. Some of it will be wrong. Don't know why. That's just the way it is. Since originally publishing Effective C++ at the end of 1991, I've done my best to fix errors in the next edition of the book. He gets reports from his readers, and then he links them and everything, and he says that sometimes the bug reports are valid, but some of them are not. And he goes on, some readers may assume that the compiler they use is standard conformant, but it's not. Sometimes they're unaware. Anyways, when he gets one, he has to evaluate whether it's valid, and he basically just doesn't trust himself to do that anymore. So, and that's only after retiring for 2.5 years. And he doesn't, yeah. So that was at the end of 2015 is when he stopped doing that. But anyways, read his books. They're great, but also give this article a read. C++ is such an enormous language, and there's too many features, so your best bet is to learn a small subset of it and just stick to it. But yeah, actually have had to do that because pooling function objects will mean nothing if you go over the heap anyways for every object. So now I have my own 80-byte sized function. Also helps avoiding file sharing with other members. Nice. That's what I end up doing too, is creating a lot of my own data structures and stuff because it's just easier that way, which is very sad. Okay, so anyways though, let's go ahead after that tangent. We want to do that. We don't want to do that. We want to do from.parent ID. So we just want to copy things. Let's go ahead. We're going to copy all of this memory. So we're going to say from.nameLength equals res.name, or no, wrong way. Res.nameLength equals from.nameLength. Gonna do that. Get rid of that. This is gonna be from.name, and that should be good. Okay. Set this to status. That. Okay, rotation. We're gonna copy all this stuff. Eventually I'm gonna get rid of this because we won't need it, but for now, we'll just keep it. Oh, and actually I need to change this too. So this equals that. Okay, we got that. Got that. Basically just doing all this stuff. Okay, now this one is gonna be SVG create default. Okay, I lied. This is actually gonna be like G memory allocate. Okay, do that. Do that, and then we're gonna go ahead and say object equals yeah, so that, and then yeah, okay, and then I need to do this. This is the result of several very bad API decisions, which I wish I hadn't done. So we're gonna do star there, which should actually assign that. Several bad decisions that I wish I hadn't done, but it's too late now, so it is what it is, unfortunately. Let's do the same thing here. Do that. And then we can say copy. We want to do that and that. Okay. Let me just make sure this is right so far too, because I think I do this somewhere else. Nope, doesn't look like I do. Okay. Well, we'll keep going. Hopefully this all works out. Let me see. There's some... Worst part was research into how to store Lambda. All right, so we've got all that. I think this should be good. We'll find out. One thing I do want to check is I don't think I need to do that copy there or something. Let's see. Oh, no. Okay, I do. Cool. So that's fine. I was making sure I didn't need to allocate here, but I guess I do need to allocate there, and I think I need to also do that in order to make sure this is right. Okay, anyways, we've got that. From.isTransparent. From.draw debug boxes. From.draw curve. All right. That's not what I wanted to do. No idea where I just went. Okay, let's go back to where I was. There we go. All right, so we got that from .stroke width. Let's do that. Also, it looks like it's very easy to accidentally come up with God objects that just do everything. No matter how much you intend not to create them, sometimes you just end up with that stuff. So, unfortunate, but that's the way it is. All right, so let's do, we don't have to do that. We can do from.position start. Which, did I already do that? I did not. Okay, so we want that. And res dot. Okay, looks like I'm gonna have to add some other things here too. Do that. And that. Also, somebody just followed. Vactrol, thank you for following. Good to see ya. Let's see if we can make some progress today. I hope we can at least get something done tonight. We'll see. Let's switch on type. I need a semicolon. Okay, we'll do that. And we're gonna do from.object type nano z byte. Thank you for following. Wouldn't say lots of data make something a God object. I guess that's technically true. I definitely feel like, oh, I'm forgetting a semicolon again. I keep missing these simple things. I guess that's technically true. This is definitely, I feel like it has more data than it needs. I at least want to categorize some of this. Like this, all that stuff should be a transform, not just scattered in this object. And I should be using more components to kind of compose the object rather than just stuffing it all in here. And these should be an enumeration, like or a bitwise combination of flags. It shouldn't just be booleans. So there's a lot of stuff that I want to change that I just haven't gotten around to. And I guess there's no better time than the present, but I'm going to wait. Okay, so we're going to switch on this. I want to make sure that we copied everything too, though. And this is where it gets, so like if I had these as sub-objects and stuff, it would probably make this a lot easier to handle. Because then I could just do like transform copy and then figure that stuff out instead of having it all kind of stuffed in here. Let's just make sure. So we've got ID, parent ID, name. Okay, we've got that stuff. Status, type, rotation, scale. Let's put position up there. Position. I think I have position global. It's also something we want. Global position start. Res.position. Or I guess global position equals that. Okay, we'll do that. Let's see what else. So we have global position ID. We did that. Generated children IDs. Okay, I guess we actually technically need to copy that too. So we'll say res.generated children IDs equals from, and I know that's going to copy a vector, but that's the point. So we're going to do that. We have name. We have that done. We have that. I think we have that. No, we do not. Okay. Oh, wait, yes, we do. Right there. Cool, so we got that. Status, we've got all the flags. All right, I think that's it. So we have all those, and then we have this stuff, which is like the sub-object stuff. So let's get rid of that. This would be... Maybe we can just do this. I don't know. Let's check it out real quick. No, we cannot. We actually have to copy that. Okay, so let's make some copy functions. Create copy, and this will take in that guy. Cool, so let's do that. Text animations.cpp. That's right below create default. All right, so we'll put it right here. let's go ahead and get that, which is going to be similar to this. Okay, so this is going to be from.font, which I think that's a std string. No, it's a font star. That should be fine though. So fonts are pointers, but it's okay. They should persist. Wait, should they? I don't know. Wait a second. Let me just double check that because I'm not quite sure. Okay, yeah, so I need to actually load the font. So instead of doing this, that is what we're gonna do. And we're gonna take it from this guy. Ooh, okay. Let me see how we can do this, because I think there's a few different functions in here. It's been a while since I've been in this code, so I'm kind of rediscovering a lot of it, which is unfortunate. So I think what load font does is it increases a reference count. Yeah, so what it does is it basically looks for it. If it sees that it increases a reference count, that way it only unloads it once all references have been unloaded. So ideally, I'd like to just load this. But it looks like in order to do that, I would need to pass that in. But I'm just going to do null pointer, and we'll see what happens. Anyways, what's wrong with this? Let's do that. That's better. Okay, and then what we'll do is we'll just go into here. And if we get down to here, do we even use this is what I'm wondering. Okay, yeah, we do use that down here. So we'll just say this. Okay, so basically what should happen is this font should already be loaded. So we should just be increasing a reference count, which means we don't actually need this. And if it does need it, then that's a problem, and it'll be a good thing that it gets null pointer there, because then we can go and fix it. So anyways, yeah, let's go ahead and we're gonna do that now. This is gonna be that. This is gonna be that. And we're gonna do from dot text length, okay. We need to do +1 there. Let's do that. Yes, we need to do +1 there. So let's add 1 to this. And technically we should be multiplying that by size of char, although it doesn't matter too much. Okay, that way we can add in that null byte. Cool. So that should be that. Hopefully that works out. I hope it should. We'll find out. A lot of this is just like, I hope this works, and we'll kind of find out as we get into it what's broken and what's not. So anyways, what we can do is we can say that's equal text object. Is it called? Okay, yeah, text object, create copy. All right, there we go. So that'll create a new one, and then we have that copy. We basically want to do the same thing here. I'm just gonna put to-dos for now. Copy. To-do, copy. This one's easier because it doesn't really have much. Well, it's kind of easier. I don't know. We'll put a to-do here as well. And then I'll fix all this stuff once we get the proof of concept working. So we'll do that, and do that. Okay. Okay. Cool. So that should copy the object. Now that I'm thinking about it, objects can have children. And I'm wondering if I should copy the children too, but technically they're not part of it. Yeah, okay, we don't have to worry about that. So this is all we'll do. This is good. So we have a way to copy objects now. Let's go back to build snapshot, which is in Animation Manager. Okay. And this is all we wanted to do was say create copy. And in order to do that, we need to give it, let's see, just the object. So we want to create a copy from this guy. Yeah, cool. That works. All right. And so that should copy everything. And then we emplace it. All right. I think this might be important. Maybe, maybe not. For now, we're just going to ignore it. I think that's important. Let's leave a note. Is this important? I think it used to be, but I have to revisit this stuff anyways. So, yeah. Okay, then we apply any changes from animations in order. So, we're going to do this secondary. So first, what we're going to do is we're going to go through, do all that. All right. Then we're going to go and do this. So first, we reset the state to the beginning. Then we want to apply each animation up to the current frame. Okay. So we'll go do this. We go through each object. Let's see. Oh, this is through each animation. We check and see if the animation applies. If it does, we go ahead and apply it. And then what is this doing? Oh, then we apply the transformations from parent to child. And then we update all the children. I'm seeing if this still makes sense. There's a lot of stuff in here that I didn't remember. Then we render things. Okay. And what does render do again? Okay, yeah, so that should be fine. Once we get to that point, we're pretty good. Okay, so we don't need to do this when we're creating a snapshot. We do need to do all this stuff though, I believe. So this is basically going to go ahead. It's going to apply animations up to the point where we are, which is frame start. Is that correct? We have absolute frame here. Ah, we do want to change this though. So we want that. We want that. Let's get rid of that. That's just old notes. Okay. Okay, that's fine. Do I even use this? I guess I don't. Okay. So I guess this doesn't really matter since I'm not using it. But this does matter. So we need a NVG context star. Let's go ahead and add that up here to build snapshot. So we apply each animation, and then we go and we apply each of the transformations from parent to child. Yes, okay, so now I remember what this is doing. So basically what this does is this finds all the parents, the global parents, the ones that don't have any parents. We push those to a queue, and then we do a breadth first search. That's what I believe this is doing. And this basically goes ahead, it updates the global transform by using the previous parents transform, and then updates all the children. which should just apply transformations recursively. So if we were to go look at that, this isn't actually going to do anything yet because we're not using this build snapshot function, but eventually we will be. But I can kind of explain this global transformation, how the transformations work and stuff, because that's something that I always get confused a lot. And I think I've come up with something that works pretty good. So, right, so if I take hello world, this is one object, but it has several children objects, right? But if I grab the parent object and move it, the children move, and you'll notice that it stays in sync with the mouse. It's lagging behind by like a frame. But that's because of GLFW. I can't really fix this unless I do some stuff that I haven't wanted to do right now. But you'll notice the text all moves in sync and it stays together perfectly. But if I change the position of one of the children and then move the parent, it stays in the same location relative to the parent, right? And so the way that you can do that in code, or at least the way that I chose to do it, is I basically I collect all the root objects, which are these guys. I apply whatever... I set their position to the position it is, and then I go through each of his children and I go, okay, now apply the transformation matrix. So I just apply the parent's transformation matrix, multiply it by this guy's local transformation matrix. And then if he has a child, so like say I go and I create a square. Yeah, so we have a square and he's the child of him, right? Now he is positioned relative to him, right? So he's positioned relative to him, and he's positioned relative to him, and it all just kind of works out. And then if I were to change this, I actually don't know what's going to happen here. Okay, yeah. So if I change that, we actually end up losing that square object because it regenerates all these children. So I might change the way that works in the future. But anyways, that kind of explains how that stuff works. The scaling also works the same. So if I increase the scale up here to 2, you'll notice it scales all of the children. Whereas if I were to decrease this to 1, and then increase him to 2, it only increases his scale. Which one did I change? I think it was this one, right? Yeah. Okay, and that's interesting too. And since I increased the scale down here, it's moving it too. And the reason it's getting moved is because of the way it's getting applied. I may have to look into that. Now I'm curious though. Oh yeah, so you can see like if I rotate it, it's rotating around this point. Is what I think is happening there. No, it's rotating around a different point. So yeah, everything kind of works, but it's all kind of weird. If I were to rotate this guy, whoops, we'll put that there. You'll notice it rotates each of the letters in place, which is also interesting. So yeah, all that to say, that's what this whole thing is doing, is it's doing all that stuff. Okay, anyways. Cool. So we have this new snapshot. We do that. We emplace that. Then instead of doing this, what we're going to do is we're going to loop through each object in the snapshot. Okay. Then, yeah, okay, then we're updating the actual snapshot objects. And then they should be at the appropriate location. So by the end of this snapshot should have everything it needs. Let's do scene snapshot. We're actually going to return a star there. To keep the internals of how this works hidden, first of all, and then second of all, just because this is a big object, we don't want to be copying it. So do that. Do this. This actually isn't going to work right because of the way this object is created, so I'm actually going to do that. Well, okay. We're going to do this. Okay, we do that, and then we're going to do a placement new. All right. This placement new is basically going to call any constructors we need, okay? So the reason I want to allocate it using this is because this is my custom memory allocator. It keeps track. It lets me know if I'm leaking memory, that type of stuff. So basically what we're doing here is we're just going to go ahead and call placement new, which uses the memory I allocated here and calls constructors and appropriately does C++ stuff. And the reason this is needed is because if we look in here, we have vectors. And so vectors are complex objects that need their constructors called, which does not happen if we just allocate memory. All right. Oh, that's for free. So let's go back into here. Let's change that to an arrow. If you guys watch Zoding Daily, I remember he did a stream where he changed the syntax that dots worked for arrow notation as well. And it took him like 15 minutes, which was just kind of funny. Don't know why we have this syntax or why it's necessary. Why can't everything be a dot? I don't know. Anyways, we've got that now. Then what we do is we just want to return our snapshot. The other thing that you have to be careful of is if you do what I did up there, I guess this is called res. No, what did I call this? I called it new snapshot, didn't I? Yeah, so if you do this new placement thing that I did up there, you just have to be careful and make sure that like when you actually delete this, you call the destructor manually. And I think it's like that. Yeah. So if you want to delete this, you just need to do that. And then I can actually free the memory safely because it does the same thing where this will just call the destructors as necessary and make sure that stuff is good. And then I free the memory I actually allocated there. Okay, so doing this, we should be able to build snapshots now. Theoretically. We want to actually use this now, see if it works. So now for the scary part, right? We should have our starting snapshot, current snapshot, and then just a list of snapshots. Now, how do we get our starting snapshot is the question, I guess. I guess the way we get our starting snapshot is I have an init function in here somewhere. Ah, thank you for following. Me Shuga 86. Thank you for following. Good to see you. I probably said your name horribly wrong too, and I'm sorry about that. So okay, so we have something inside of here which should initialize things. So this is kind of what we just copied from, and we're about to remove that and use whatever current snapshot. Yeah, so like we have this thing. Basically what we can do is we can just get rid of this. Right? This is the hope. We can get rid of that, and then we can basically just like find current snapshot or whatever. I mean, we don't even have to do that too. We just use the current snapshot. And that's how this is kind of going to work. And then I guess I could say if delta frame does not equal 0, what we want to do is we want to say like find the next snapshot. So we want to be like find snapshot. We would do this frame equals that, and then we would just find it based on our current frame. And then we would just do that, I guess. Whoops. Yeah. Right? Something like that. That's kind of the API I'm going for. This way, now what's going to end up happening is we don't actually render everything, right? We only render whatever is being here. And what this is doing, this is actually just like, I say render, but it's just like grabbing whatever's in the cache. And this is how I want it to work. Trying to think if this is actually going to work right. And I want to say yes, this should work right. But how do we get that initial snapshot, the snapshot 0? And that's what I want to find. And I think what we can do, okay, yeah, when we serialize, this is where we're going to be doing it, and deserialize. Okay, so this is kind of where we're going to build that initial snapshot. All right, so when we deserialize, we go through this. That's the animations. And okay, here we go. Instead of current snapshot, this is going to be starting snapshot. Okay, so we are going to do that. Let me just make sure that I didn't miss stuff there. Okay, so this is serialize. Cool. Okay, we just went past it. That should be good. So now when we deserialize, let's just go back down there. We get the animations, and then we initialize the starting snapshot. We do that by deserializing an object, and then we just push it into the objects of the snapshot. Yeah, and I think this should work. This is all we need. Okay. So now, based on that... Oh, wait, and then we also have to do one last thing. So we do that... Trying to think of how this is going to work. So we do this. Let's change this to a pointer. Pointer. Wait, I'm kind of... Now I'm kind of torn. Do I actually want to do these as pointers? I don't think so. This is when it starts getting hard. Okay, so I don't think so. I think I want this to just be arrays. Okay. So let's rethink the API down here a little bit more. So we currently have this, which isn't going to work correctly. So let's go ahead. We're going to copy this out, put it up here. And then this is going to return a copy. So we're not going to return pointers there. I lied. We're going to do this a little bit differently. So right here, let's just fix that. And we're going to fix this. We're going to fix that. Going to fix that and a few other things. That as well. And this. Okay. Yeah. So that's how we're going to do this instead. So we do that, which means that when we copy snapshots, it's literally going to copy these objects, which means it'll copy this entire vector, which contains a lot of state. So this will be a pretty big operation is basically what I'm trying to say there. Building a snapshot, which is fine. And when we deserialize, there we go. Okay, so when we deserialize, we're going to go ahead and call that. We push all the objects back, and once we finish this, I'm going to say am current snapshot equals am starting snapshot. All right, so then we make a copy there. This copies everything. It should just work. But it's not going to just work for reasons that I should have thought of earlier. Well, actually, okay, so what we can do is actually we can test our build snapshot function, right? So we do this. This sets up the initial state. We're good there. And then we can say this equals build snapshot 0, which is the starting frame, which is the frame we're currently on. Or it's not, though, because we're actually on a specific frame. Okay, so this is what we're going to be doing. Let's see if this works. How's it going, Voxriffs? Good to see you. Do we actually need this too, is what I'm wondering. So let's go back to deserialize. Let's go there. That's this. Okay, so then we reset to frame. Whoops. Where is this getting called from now? Okay, we're gonna have to go back into this deserialize function and just add one more thing, which is nano or NVG context star VG, which I don't like doing that too much, but it looks like it's necessary here. Okay, we'll do that. Do that. Then after we do this, we can say AM current snapshot equals build snapshot. And now we can use this, this, and that. Okay, cool. So what should happen is we deserialize everything. That sets up the initial state. Then we can build a snapshot based off that state using the current frame, and that should build the appropriate snapshot. Then when we get into render, which is up here, we have all this stuff. And what we'll do is, instead of doing this, we eventually want to do like find snapshot here. But for now, we can just say this equals build. Okay, and then we're going to do that. Right, and what we actually want to do too is we want to make sure to free whatever we have there, because this will have some data that we need to get rid of, stuff that we've allocated. So yeah, so we'll do that. But we'll do that in a minute. For now, let's just try this. Let's see if this works. I have no idea what's going to happen, so it's going to be interesting. Oh, we're going to get an error is what's going to happen, because I changed the API of one of those functions without actually fixing it. So we get an error, but that should be easy to fix. It's all better. That was easy. And I think we should be good. That should be fine. We'll see. Who knows? Maybe we'll get a runtime error now. So we get this, we got a runtime error now, which I guess is to be expected. Okay, so this is happening when we create a copy. It's not happy with this. Why is it not happy with this? This is null. That's not good. So I guess another good thing to do would be is say if res.svg object. We'll do that. We'll do that, and that should not be res, that should be from. And we'll initialize them to null. That way we don't have garbage in there. Okay, and that's actually res is what we want to do. Okay, let's see if that works out for us. Probably get a little bit further and then get another runtime error, but we'll see what happens. Okay, we got further, and then we got another runtime error. Anim object was null, which is interesting since I'm passing it in as a const reference. Not sure how that was null. I lied. I am sure how it was null, maybe. Oh, it's because of this. Probably. Okay, let's see what's happening here. We should actually step through the code, which is what I should have done from the start. So let's put a breakpoint here. Let's restart this. All right, so we get into here. We do this stuff. We do all that. Initialize, 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 that stuff. Scene systems, let me just make sure. So we do that stuff. That's fine. Oh, and I'm in release mode too. I'm going to get out of release mode real quickly. So whenever you're debugging in C++, it's very important to debug in debug mode, because if you don't, you're bound to get the breakpoint jumping around in weird places, and then you'll have stuff that's been optimized out, and you won't be able to see how everything is actually performing or what's actually happening. So yeah. If you notice that you're like trying to step through code and it's not stepping one after the other, either you're multi-threading in another thread and you're in some thread context, or you're in release mode. It's usually what's happening there. Okay, so let's go down. We hop into here. Okay, we do all that stuff. This is important. What happens here? Okay, so we do a placement new here. That's fine. Okay. Then we hop in here. That's fine. Okay, then we load the project. This is where I have a feeling we're going to have some weird stuff happening. So let's go into here. We open the file. We do that stuff. Okay, that's fine. Okay, then we deserialize. Oh, wait. Yeah, I don't think this actually matters. Okay, let's get out of here. So we deserialize that, then we load. This is what we want. Okay. There we go. So we hop into here. Okay, we get that stuff. Okay, we get into there. Let's see what happens in here. So this is what we were just working on. This should go ahead. Let's go back up here. Let's continue to here. So after that finishes, what we should have is we should have the first snapshot, like beginning snapshot. Should have some stuff. Starting snapshot. Okay, yeah. So you can see we have 48 objects in there, and we have 48 objects in the ID map. And if we look at that, that looks correct. So this is basically mapping object IDs to indexes into that array. And I'm using uint64 there, so we should have no problems with running out of IDs ever. We do that, and then the build snapshot. This is where things get interesting. So let's see what happens here. So we do that. Create copy. Let's see if this works. Okay, this goes there. We create some memory there. Cool. And that looks correct. Hello world is exactly what we want it to be. We set the status. We do all that stuff. Okay. No SVG objects, which sounds right because this is the parent, which doesn't actually have SVG objects. So we go, we get all that stuff. Create copy. This is where it could go wrong. Okay, so we load the font. That's fine. And it looks like we got the correct font there. Yep, that's all good. So even though we passed a null pointer there, it used the cached font, which is good, which means it just increased a reference count somewhere. We have text, which is almost good. Once we put the null byte in there, there we go. Now it's good. Is that correct? Yeah, that's correct. Cool. So we got that. Looks like it created the text object fine. Okay, so we return that. Wait, yeah, that's fine. I think that's fine. Okay, then we go into here. This is going to be one of the text object's children, I think. I hate it when I have to go through all this stuff. I'm pressing the wrong... Oh, crap. I just missed it. Okay, so what did we just put in there? We put in another text object is what it looks like. Yeah, so this is a text object and it says goodbye. Okay, so that's fine, I think. Which one is this? This object. Okay, so then we get an SVG object. Okay, and the name is G. So now it's doing the letters. So that's good. So it's actually, let's go into one of these. Copying letters now. So if we look at the name, this one is O, which is the letter O. And so that means we should see it hop into one of these. Yes, okay, so we hop into here. Okay. Did that do anything meaningful? It doesn't quite look like it. We just set everything to 0. Okay, that's fine. But we shouldn't have. Okay, I'll have to fix that real quick. So we just need to make sure to copy stuff there too, I think. But this one is fine. Okay, that's fine. So one thing we need to do is we need to add this there, and we just want to change that to that. Okay, I'm not going to compile that because I don't actually want that to save yet. Oh, but it's going to do that anyways. Okay, we're just going to have to stop real quick. Okay, so that looks good so far. It looks like it's copying things all right. So the deserialization, I'm assuming, is working. So let's go back to where we were, which was inside of here. And then I think we were in here. And we were at what point? I think we were right here. Yes, okay. So we were right here, deserializing. And the deserialization looked like it was working fine. If we look at it, yes, that looked fine. And then we were in here. That's what we were doing. Copying everything. And it looks like this is going all right too. So then if we were to jump down to here, it should update everything as needed. Yep, so we start applying the animations as needed, which is good. So that looks fine. By the time we get to the bottom of this then, so once we get down to here, new snapshot should have 48 objects. Ah, we never did the object ID map. Okay. So that's one of the last things that we have to do too. I think that's probably why we broke. So we do this, and then what I want to do is say new snapshot dot ID map. This guy's ID equals that. Okay, so we just create that map, which maps from the ID to the index, and we should be good now. Let's see. Continue. All right, so we're good. It's not broken, but moving that cursor shouldn't actually... Oh, wait, it is building snapshots. I forgot about that. So that's kind of lagging things, but we're not seeing anything either, which isn't very good. So we need to fix that. Let's go into here. It looks like it's building the snapshots, though, and that's all working. Let's see. Where do we... Okay. No, yeah, when we do this, it shouldn't actually lag when we move the cursor around, which is interesting. Oh, you know what it is? I think... No, yeah, okay. Let's go. So if we go into application, let's just double check things. Oh, it's right here. Okay, so what happens when we change the frame? It clears the SVG cache, which is fine. And then when we call render, we should use our current snapshot, which is what this is doing. Okay, and then this should just render it if the object is alive. Let's see what happens. Do we ever hit this? Okay, we are getting inside of there, so that's interesting. Okay, and then we hit it again. And again. Okay, yeah, so we're definitely rendering stuff. That's interesting. What's this doing? That looks fine. As does that. Ah, I wonder if this is... Okay, wait, let's see. So we go here. Ah, okay, so yeah, I think I need to change this stuff too. So get object. Yeah, we just need to fix this, and I think we should be good. Current snapshot. No, this is fine. Okay, so we're using the current snapshot, which is what we should be doing. To render things, okay. That looks right too. As does that. Serialize looks wrong though. This should be writing out, ooh, and I hope I didn't break things here too. This may have broken some stuff. This should be writing out the start snapshot. Okay. Yeah, so I might have broken some stuff, which is why we're not seeing things. So we should be saving the starting state of everything. And that should automatically like build the rest of the scene once we get into it. Okay. Yeah, and then we should automatically build that. I think it might be too late to fix that though, which is unfortunate. Let's remove that. Yep, and it lags very badly when we start changing things. I wonder what happens if we do that and then we go back in real quick. Looks like not good things. All right, so it looks like we've broken things, which is not good. And now we're leaking memory too. So all sorts of not good. Uh-oh. Okay. I do think we've made a good start on this at least. Like, I definitely have a better idea of where I want to go with this. It's just getting kind of late. Not very late, but my brain isn't working as well as I'd like it to be. So I'm going to have to work on this more. But let's just take a look at where we started, because I've broken things. I haven't actually made things better in this stream. So let's go ahead. We're going to do this. Let's add all this stuff. Break a lot of stuff and optimize nothing. So that's what we've done. Cool. And then let's just go, we're going to say, how do I go to a specific commit? I always forget git syntax. Let's see, git, go back one commit locally, just in case. We're going to push this too, because I don't want to lose anything. So we're going to push that. It's broken. That's not good. And then what we can do, we can actually just say reset head tilde1. And if we look at where we are, yeah, so now we're just back here. Okay, so if we look at where we started at least, I'm going to do a new project too, because actually I am interested. What happens if we open this up now? We get nothing, and it's still very slow. I wonder if we actually reset there. We did not. I don't think we did. Which is interesting. Do we have, yeah, okay, this still says snapshot. That should not say snapshot if Git is not lying to me. Right? Because if I go back, it says we're here. Interesting. Yeah, and we still have this. That's really weird. Maybe git reset doesn't work the way I thought it did. Oh, maybe git reset does work the way I think it does. Wait, let's see. Where are we now? Okay, yeah. I'm not doing the things I think I'm doing is what I think the lesson here is. Let's go back here real quick. Okay. That's fine. I'll fix that later. Let's go here. Check the commits. Okay, yeah. So I pushed this here. That's good. So I at least have the changes here. I didn't lose anything. Let's go ahead, copy that. Let's go ahead and check that out. Nope, that didn't work the way I thought it would either. Okay, here we go. So now we have our log or our git back at the correct location at least. I was trying to just go back a commit so that we could at least see what happened and stuff and then go back here afterwards, but not working the way I thought it would. And let me just make sure. Okay, that's good. Let's see if we can just get temporarily, because this is all I wanted to do. Ah, so we just check out. So let's do that real quick. Whoops, that's not what I wanted to do. Let's do that, check out. There we go. Okay, so now if I go back in here, there we go. Now the code's going back. This is what I wanted to do. Okay, so now if we run this, we can at least see where we started and stuff and see where we're kind of heading towards. Does anybody else have that problem where every time you want to use Git, it's like everything breaks again? Or you have to refigure it all out? Like no matter how many times I use it, there's different things I want to do and I can never remember how to do them all. Okay, so let's call this hello. Go ahead, add a track down here. Add this, add that. I really need to optimize this flow too, because this is very painful to just set up a scene. Eventually I'll get these things optimized down though. For now, make it work. Okay, cool. So we got that. It's pretty slow when I'm moving around, which is unfortunate, but that's the whole reason we're trying to do optimizations. Let's just grab our metrics and make sure we can kind of keep track of how fast we're going. So 60 FPS. When I move around, it drops down to 20 FPS, and this isn't even a lot. So that's definitely why we want to change the way this behaves currently, because that's not good. Yeah, this is in debug too, which is why it's going so much slower right now. But yeah, I had the same problem today with git stashes. Yeah, it's and no matter how many times I do it, it always ends up, I always have to do a bunch of stuff because I never remember the exact syntax, everything. But anyways, this is where we started from. And the whole reason we're making these optimizations is because when I move around out here, it lags like crazy because it starts re-rendering this cache when it doesn't need to. And so that's basically what we're working towards fixing with that whole data structure thing and everything. So yeah, hopefully I'll get closer to that goal pretty soon. But for now, everything's going to be broken. And I think that's the way I'm going to have to leave it for this stream. Let's go back. So now if I do this, there we go. Okay, so now we're back at where we started. There we go. Cool. When Git works the way I think it should work, it's great. When it doesn't work the way I think it should work because I use it wrong, it's really bad. All right, guys, I hope you enjoyed the stream. Hopefully you gained something out of it. By the next stream, I hope to have this whole concept finalized a lot more and hopefully working so that we can actually see the improvements. And like you saw before, it was lagging really badly doing no changes. The goal is by the end of next stream, it should be running 60 FPS no matter what's happening. Pretty much no matter how big the scene gets. That's the goal, ultimate goal. We'll see if we can get there. Anyways, thank you guys for watching. I'll see you guys in the next stream. See ya.